Yishai, welcome back to Dev Interrupted. It's been great having you running DI Hebrew, which I want to shout out here to start this off.
Yeah, it's awesome to see the local response and really great content, great guests. We love to have the Dev Interrupted brand behind us.
And for those who don't know, if you're a Hebrew speaker, want to check that out, you can find that at devinterrupted.com or across all the podcasting apps. It's hosted by Yishai, the CTO of LinearB. And he's here for a really fascinating conversation today on the original Dev Interrupted show. We know that the closest analog to language loyalty in programming might be sports. People are invested in, protective of, and faithful to their favorite team and their programming language of choice, whether it's Python or whatever else you might pick.
Yep. Or church.
Yes, church. Religion's a great example too. The major difference between, sports and programming language, though, is that teams actually have a win-loss record. So you can objectively say, oh, this team, my football team, they lost, didn't score enough goals, right? We know how they perform. Until now, we haven't had that with programming languages. We didn't have a way to judge how efficient, streamlined, and constructive they are. And from what I'm hearing, Yishai, that's changing now with LinearB's new research.
Yeah. So, we're very interested in the process and the experience that developers go through. How do their daily lives look when trying to get work done as developers? And obviously, the programming language you use as part of your tool set has a lot of impact on your experience and the way you collaborate with your teammates to get your code ready, reviewed, eventually merged, and in production. So it was a very natural thing for us to look at to see how does the choice of a programming language affect all of these things.
So I think it's a great fit for this kind of LinearB Labs format, where we dive into the most interesting research of the developer experience and how to use that information to improve engineering organizations, streamline code delivery. And I'm really excited to talk about this more in depth on the show and dive into what the LinearB Labs data team found out about how developers are experiencing their programming languages. What languages have the most PRs, or the longest ones, which one labor under the largest sizes, crossover, and more. So great to have you on the show, Yishai. I'm excited to see what you want to dive into.
Yeah, I'm excited to be here, and really interesting what the research shows. We focused naturally on the things that are most crucial to the effectiveness of the team and to the ability to get work done. So you mentioned how long do the PRs live for? What's the required process, and how long does it take me to get my code reviewed, which is a crucial piece of the developer lifecycle. And then another angle, which is crucially important, is how large are my code changes? Am I able to make very minimized, very clear, elegant changes to my code to get the effect that I need? Or do I need to create a monster that then is very difficult to review, very complex, a lot of code lines are changing and so on. And programming languages apparently have some impact on those numbers.
I'm really excited to dig into that data, and I want to give the audience some context about you first. So they probably know me at this point. I'm the co-host of Dev Interrupted. I host our LinearB Lab session, Connor Bronston. Great to see y'all again. But before we jump in fully to this incredible data report you're bringing to us, I want to understand the context around you, Yishai, so they know how objective these results are. Are you biased about one programming language or another? What programming language did you learn first when you were starting to learn to code?
Yeah, so the first language I learned was Logo. I don't know if you're familiar with that. Some of our listeners maybe I'm showing my age. So that was back in like 6th or 7th grade. And this was, Logo is a language about moving a turtle that draws on the page with commands like pen up and pen down and turn right 90 degrees. And I remember actually programming a very neat analog clock that would draw the actual hands, move them every second. And when you move the second hand, you need to delete it and draw it again at the new angle. And then remember to redraw the minute hand if you happen to delete it together with your second hand and so on. I was really proud of having a clock with 3 hands running through the whole cycle, all in Logo. That was my first language. And then a bit later, I think at the beginning of high school, I started to learn C. So I went to this class where I learned C from the Kernighan and Ritchie book. It was, the original C programming language book. So these are my two, like my toy language, which I learned first, and then C, which I actually learned to do things with.
So when you started your career, were you using C? What were you using in those first few jobs as you're kind of becoming the engineer you are today?
Yeah. So my career, I began writing code as, in the military service. That was part of my initial work as a programmer. And that was mostly C, some C++. I actually got the chance to write a programming language as part of that work. So that was a very like a combination inspired by Java. It was the early days of Java at that time. I'm talking about
Yeah.
like early 90s. So inspired by both Java and Python, but there was like a unique requirement about the running model that forced us to implement a new language instead of just taking one that existed. So that was one of the, my deeper incursions into programming languages as a subject. That was a very interesting experience. I was pretty young at that time, probably, about 20 years old. And to me, it was fascinating, like looking at grammars for parsing the languages, making decisions about virtual machine for running the actual innards of the language, the mechanisms for running the stack or simulating the stack for passing our variables into and out of functions. It was all new to me. It was, and when things actually worked, that was amazing.
It's great context to have this because it tells us that you've kind of been there, right? You've helped create your own language.
Mhm.
You've worked through kind of the iterations of languages as you can see them changing in ease of use, maybe, and other ways. So it's awesome to have that context. I'm excited to have this conversation with you because I'll say on my end, right? Like I first learned programming with HTML and Java, just like creating web forums, for my friends and I to talk about online games. So it's great to have the context that you bring of like, hey, you've actually built a language. You've gone back, you've used some of this early stuff. And I think it's going to really inform this conversation. One last question on this topic before we dive into the actual numbers. What languages have you used to build LinearB?
So LinearB uses mostly Python in the backend. We use Node, so it's basically JavaScript and TypeScript for like a mid-layer API layer, and then we have React, which is again mostly JavaScript, TypeScript for the front end. So these are the main like 3 or 2.5 languages that we use in LinearB. Some of these choices made before my time, but totally agree. My go-to language is Python. My like native language is Python. That's the one I spent most of my career working in. My early career was C, C++, some Java, and then I used Python as a more like a plaything. But then after a few years, began to do more and more Python, and that is for anything new, that is my natural go-to. And
It's become such a basis, right? And it's
it
so
has,
kind of well known throughout the industry because to your point, it started as a play language and now it's like, no, like we build a lot of baselines on this.
yeah, it's become the language to learn if you're starting out. Has a tremendous, library set and so on. And to me, it's still the easiest and most natural language just to get started with. There are some cooler kids on the block, and for some tasks, you probably have reasons to go elsewhere. But for me, that's like if there's no compelling reason to do anything else, I'm going with Python, and I'm saving enough time by just doing what I'm familiar with and what is already proven, and is very elegant and easy to read, and all those reasons why a lot of people choose Python.
Well, let's see how Python stacks up to the rest of these languages in our study. Dive into the best and the worst programming languages in terms of workflow. I'm not making a firm stance here. I know, don't crucify me here, folks. Can you give us maybe a sense of how you can measure workflow for programming languages so we can understand that context in the study?
Sure. So we're basically looking, and when I say we, I'm talking about my data team and LinearB. We're looking at what actual developers do, their activity on Git in the context, typically a commercial setting. It's not open source projects. These are people getting paid to develop code at thousands of teams across, many organizations, large and small. That's the setting. So This is about teams working together, getting paid to write commercial software for their companies. And by looking at the way these people interact in Git, the way they create pull requests or merge requests, the dynamics for getting the code reviewed, eventually merged, that is our scope into the workflow or procedure questions or process questions that we are focusing on. I'm not going to talk about which language creates more bugs or which language is harder to understand, but if consistently code or pull requests made in a code base in one language are much longer to review and much longer to get merged, that is a signal for me to say there may be a link between the choice of language and the different behavior we're seeing in getting this, the code changes reviewed, approved, merged, and so on.
So we're looking at PR lifespan as a measure of workflow efficiency on teams that are using these languages.
Right. The time from when the PR was created and not as a draft, but real PR ready for review and until it was merged, that is the lifespan. And it typically consists of both the dynamics between people I need to know that I have to review this. I need to actually go and review the code. I need to understand it to some degree to be able to review. Ping pong between people to process through the review comments, make changes, get to an agreement, and then finally get that merged.
And this aligns with our previous LinearB Labs episodes talking about that PR lifecycle as the sticking point in today's development process that increased cycle time of teams makes them less efficient.
Yes, it's a crucial piece of both of the developer experience day to day. I finished my work on a ticket or a bug fix or a new feature. I want to get this delivered. And the first main hurdle, and it's taking a lot of time, is this has to get reviewed and merged before it can hit the other, like the automated CI, CD, all those investments that, we and many other teams have made need the code to get merged before they can start, acting. And because that process is heavy with human interaction, it's very, it's hard to get it right and hard to optimize it. It's not just machines and code. I need to get someone to actually help me.
Yeah, I think this is a great way to kind of approximate efficiency across languages. So let's dive into the numbers. Which programming languages are laboring under the longest lifespans? Who are the losers here?
So we're looking at, a little over 500,000 pull requests. That's the data set that we have chosen for this research, and focused on pull requests that are pretty much, just a single language in that pull request. Some, in some code bases, you get a mix. So we focus on the ones that we have a clear signal on. The number one more laborious language is C++. In C++, we see a typical pull request takes like almost a week or a little over a week, 140 hours. This elapsed time from the minute you create the PR until it got merged. And that is a very long cycle. That means that, there is something here about reviewing C++ code that made this so much higher than the common thing we see across all languages is about 40 to 50 hours of elapsed time. So about
Still a lot.
almost 2 days to get a PR merged as a typical across everything. This is about 3 or 3.5 times as much for C++. So it's a
And this is based on a study of 600,000 plus pull requests, correct?
Yes, that's right.
Wow.
Thousands of teams, tens of thousands of developers. So, and C++ stands out pretty nicely here with almost like 3.5x the typical case.
Yeah, because I saw Ruby was second with 95 hours approximately, but that's a huge jump up to C++.
Yeah, so C++ is like up there on the pedestal, and then and then Ruby comes in second with about 95 hours as a typical lifespan for a pull request, which is still a lot and is still almost more than double the common case. And it's strange because C++ is a statically typed language that gets compiled. It's very explicit in its nature. And then Ruby is a dynamic language. It's interpreted. It's much more like Python in the, you have people think about typed languages and untyped languages, compiled versus dynamic, interpreted. Ruby is on the other side from C++. But I think, I come from the Python camp, and we tend to say that Python is very easy to read, very easy to parse with your eyes, understand what's going on. And Ruby is very expressive, but also very hard to read. And there's just like three different ways to do things. And you get all these weird expressions that, do magic, but they're also very hard to understand in a glance. At least that's what the Ruby, the camp that doesn't buy into Ruby says. At least the data shows that there's something in it. That
Interesting.
Ruby, again, stands pretty high. This is the second longest lifespan we're seeing. And apparently there's something that is, making review and decisions to merge Ruby code more difficult and take longer than everything else except C++.
What's the drop off to that like third place as far as longest lifespans?
So at the third place, we see Groovy, and that's about 50 hours. So that's already pretty much in the middle pack. There's like,
so there's this like two huge outliers, it seems like.
Yeah. C++ and Ruby are way out there. And then there is like 50 or 40 to 50 hours, in which you see Groovy, and then you see C and Scala and Go, Python, Kotlin. These are all around, roughly 40 hours as a typical lifespan for a PR. And yeah, C is down there with 45 hours. C++ is 140. The languages are similar, but C++ has the additional complexity, the object-oriented, the classes. Maybe that explains part of that difference. But I would say this middle pack that runs about 40 to 45 to up to 50 hours as a typical lifespan, these are all the main languages that we know, including Python, Go, and so on.
And then I saw, TypeScript hit 30 hours, Swift hit 35. So you're starting to see some like drop down as far as like lowering cycle times, lowering the workflow time and improving efficiency there. But what are the top shortest lifespans? Let's go to the other end of the chart. Who are the folks who get to brag like, hey, we really nailed our workflow efficiency?
So there's a couple on the like very low end that I'm going to skip for now because they're not real languages for me, like SQL. When you have just SQL.
Called out. Yeah.
Yeah. So SQL, obviously it's like a specific domain language. It's not a full programming languages. When you have pull requests that only change queries, only change SQL, then these come in at about 15 hours to review. That's a lot lower, but it kind of makes sense because when you only see changes in SQL, that's typically a very limited scope of change. It's just about structuring a data query. It's not about a change in logic and
Right.
order of execution. So I think it makes sense to remove that. But Java also comes in at 15 hours. And Java is a heavy language. It's, again, statically typed, compiled.
That really surprises me.
It does. And next to Java, we have C# with 16 hours. So Java and C# are of the same kind, if you like. And they're similar to C++ in many ways. They're also different in many ways. So it's surprising to see them at the other end. So
C++ is all the way at 140 hours and Java's at 15.
10 times, like the typical, about 10 times longer for the PR to get reviewed and merged than we see with Java and C#. So, despite being a bit more verbose and having some maybe additional perceived heaviness, at least Java and C# are way down there at the faster languages to review and faster and easier to get merged. Maybe people are not reviewing and are saying, okay, I can't read this, all these long class names. I'm going to just LGTM it.
Yeah.
But, joking aside, something is happening right with these languages. It also helps that languages are compiled. You get a lot of the errors up front. Maybe that helps with the reviewers don't have to think about these things as maybe they need to with dynamic languages. But yeah, that's the data we're seeing. So Java and C# are the main signals on the very best in terms of the lifespan.
That's super interesting. I have a couple more I want to ask about, but I'd love to get your take on what were the different results that really surprised you? Because I'm hearing a bit of, it sounds like surprise when you saw that C++ at 140 and then you see Java and C# on the other end. With the results where you went.
To me, that was surprising. Like the very, like how I would expect to see more like one class of languages, like dynamic languages at one end and then static languages at the other end. or procedural versus object oriented. I'm not seeing that. So having those extremes with Java and C as the two extremes that was surprising. I was also a bit surprised to see PHP come in at about 20 hours, which is again on the very low side. But then on PHP, I'm even more inclined to say maybe they're not getting really reviewed. PHP, at least in many cases that I've seen, tends to be on the disorganized, less kind of process development. I'm, probably going to get burned.
Someone's going to come into the comments here.
Flame wars, that's what I've seen again in a very anecdotal in my experience, but it is coming up as one of the shorter lifespans that we're seeing. So that was kind of a surprise.
What about JavaScript?
So JavaScript comes in at 22 hours. It's in that leaders pack, and could be a bit surprising that JavaScript is at 22 and TypeScript is about 30. TypeScript is typically, compiled into JavaScript. It is a bit more expressive, it's a bit more a bit tighter. So I would expect reviewing TypeScript to be actually easier than JavaScript, but apparently that's not the case. I don't have a good explanation on why JavaScript does so much better than Python, for example. It could also be about where is this code being used. JavaScript lives a lot in client-side code and in the browser. So completely different discipline on the impact of the code, what you need to think of, the relationship with other parts of the code base that may be more difficult to unravel when you're doing backend development. But that's just trying to create some explanation around the data that we're seeing.
Yeah. Did you have any major takeaways that you saw in the data or hot takes even about oh, this told me X?
So it helps me, badmouth Ruby, of course.
That's always fun. Yeah.
Yeah. So that's the proof. We were always right. The Python camp is right. And Ruby's out there an unmanageable language. That's a hot take. But
post in the Python subreddit. They'll love it.
Post it in the Ruby subreddit.
They'll hate it.
Yeah. I think just understanding that there's this wide gamut between languages that typically run a 15-hour cycle to get reviewed and those that take about 150. Having that kind of a wide range in itself is interesting. It's probably not just down to the language, but also, which kind of teams choose or inherit which kind of code bases. Maybe older code bases that work with older languages have a different dynamic on how they're developed and maintained. So it's not just a language, obviously.
Maybe it's a team style sort of piece of older languages typically are teams that are more stayed in their ways and maybe aren't implementing workflow changes that more modern teams are.
Maybe that, plus maybe they're working on existing products and they're doing a little more maintenance and developing new code base. These could be additional artifacts that will modify and impact the process that we're the
higher risk PR that maybe could impact a lot of current customers versus hey, we need speed. We got to build this new product.
Right. And maybe this code has been around. So if we change this, if it takes us 2 days to change it or a week to change it, doesn't really matter. We're changing a 10-year-old code base. We're fixing a bug that has been around for 5 years. Doesn't really matter if we do it in it takes us a bit more time or we are a bit more careful in reviewing and testing and making sure that everything is okay.
I'm curious about the data set here. I know someone's going to come in and be oh, well, maybe they only had a few C++ teams that were being evaluated. Are there any of these where you're saying, okay, you know what, Ruby did a 95 hours, but only evaluated 20 teams on this. That's not enough data size.
Yeah. So again, this is not a humongous data set, but it's a pretty robust one. And we've only included languages that we had enough data to show a signal. I think the number of teams or the number of pull requests that we're seeing on each language at the levels that we're seeing, I'm feeling pretty confident that these signals are there. They're real. They could be tweaked a bit if we, had 10x more data, but it's not something that I feel makes a tremendous difference.
I feel like I should plug here. If you are a C++ developer or a Ruby developer and you're hey, my team's way more efficient than that. Look, if you want to be in the data set next time, linearb.io. We have a free onboard form. Sign up for a free account. We'll include you in the data set. We'll definitely do an update of this next year. So you can help affect the data. Just throw it out there for everyone.
Yep, definitely.
So
And maybe
interesting.
the other thing to say, like programming languages is far from deciding what's going on with your process. You can improve, you can have a much tighter process and tighter workflow for getting your PRs reviewed and merged, regardless of language. There's a lot to do and a lot to, you can impact this outside of changing or choosing a programming language.
I want to dive into that one because I think it's a really important point. This is kind of a fun episode, right? We're looking at this data, we're pulling some fun takeaways. It's super interesting, but it's not like dev orgs can just dump their programming language if it's on this list. If they already built in Python, they're probably not going to change from Python rapidly.
That's right.
What can they do to actually bring PR size down if they're in a team that is having these long cycle times?
So I think the crucial piece for getting your PRs and getting the process to a very short and sweet cycle is small PRs. Like cut down your work on one thing, make one change instead of bundling things together. I'll talk about PR sizes in a bit, but regardless of language, if you are able to consistently drive the size of the code changes you're doing and have different changes in different PRs, that has a tremendous effect on quicker reviews, quicker merges, and your less risk in your reviews, less risk in your code deploys. So that's the number one thing: reduce the pieces of work and make more atomic PRs. Second, a lot of the PR review process is about people and about communication. And if you're able to effectively communicate in the team about the fact that there is a review that needs to be made, about the fact that, like, how do we choose who's going to review it? How do we make sure to balance their review queues or their other work? How do you communicate the comments back to the original person, to the issuer? Maybe know when to jump into a sync mode for reviewing, right? After 2 or 3 cycles or async kind of ping pongs, maybe it's time to jump on a call and finish the review together. These are all about communication and about people. They're not about the technology. And technology can help a lot. Tooling can help a lot in making those interactions streamlined, making them more effective, making them aware of a lot of context and like who's busy, who's not busy, what is the kind of effort required to review this PR. But at the core, can you get your team to improve their communication? That is what's going to really slice down your PR lifespan. Because you're not going to wait for hours for someone that doesn't even know you're waiting for them.
I feel like this is a good time for us to plug continuous merge. If you listen to our last LinearB episode, or LinearB Labs episode with Dan and Ori and I, we had this whole conversation about this concept of how can we route PRs better. So it's something we're thinking about. We have a free product live on the GitHub Marketplace right now to help teams route their PRs. We're very focused on this idea because, like we alluded to earlier, there is this huge issue in team cycle times that slows down getting features into production because PR lifespans are too long and it blocks a team. So if you're a team, like that C++ teams that are hitting 140 hours of cycle time, it's taking a long time for your code to get reviewed into the database. And with routed PRs using a continuous merge concept by Gitstream, there's a lot that can be done. You can check it out, linearb.io/dev to learn more. But I think there's a huge opportunity here for free tooling, team workflow opportunities to enhance what you're talking about, Yishai, which is that conversation and the team structure there changes that need to happen for some of these teams.
Yeah. So, with continuous merge, we're talking about the idea that not all PRs need the same treatment. If I can build in some flexibility and be able to say some PRs are routed to a specific process, some PRs get another process. Maybe some of my PRs do not need a human reviewer. Maybe they can be reviewed by a bot or by a set of roles and just move on. By teasing those apart, I can now stop spending cycles, stop having people spend time where it's not needed, and then have more time focused on those PRs that really matter, the ones with the longer reviews, the ones that need to get that scrutiny. So that's another clear win to get my PR review cycles and lifespans down just by not doing the ones that are going to be rubber stamped anyway.
Yeah, I think that's a great point. There's one more thing in this data I want to talk about because we have this really interesting idea of like languages that lean on other languages. We talked a bit about it, but it's obviously super rare for developers to focus only on a single language. So yeah, we may have this war between Python and Ruby sometimes, but often folks are using different languages for different purposes. They're stacking on each other. We talked about TypeScript earlier. I understand you and the team also looked at how different programming languages relate to each other in terms of real use. Could you tell me about that?
Sure. So we looked at basically co-occurrence of programming languages in the work of developers. If I'm looking at pull requests created by different people, which pairs of programming languages do we see together? Or if I have as a developer, I have some PRs in one languages, which are the other languages that I'm also probably going to see and have in my data set for that issuer. And obviously, at least today, many developers do not work on a single language and a single code base. There tends to be more of that mix than maybe was happening 10 or 15 years ago, where you had complete huge code bases in just one language and just one stack, and developers could work for years without leaving that, the boundary of a single language. I think today with a little more modern code bases, with SaaS, with cloud, you're getting this mix almost by design. So we're seeing that. And then we're seeing some auxiliary, what like I would call them auxiliary languages, like shell scripts and MATLAB that, they're never standalone. If you're pushing changes to those languages, you're probably also, going to be working in one of like the main languages, because these are typically very limited or ancillary languages for your work. So MATLAB and Shell are very obvious here. And then in terms of relationship, we see a very strong relationship between Python and JavaScript, which makes a lot of sense. So many full stackers use Python for the API or backend processing, and then use JavaScript for front end or for exposing that value into browser land or the clients. So that is a pretty strong pair that you see together. Not surprising, but that does surface in the data pretty strongly. And then I mentioned SQL. SQL again is a specific domain language, and we're seeing a very strong tie between SQL and JavaScript, which again I think is about you're making the logic changes in JavaScript and then augmenting that with SQL changes for the actual queries, the actual filling of data from your data store.
So you mentioned MATLAB and Shell, and I see Ruby here on this list as well. Where were you finding those mostly lined up? Like, was Shell aligning with Python a lot? What were you kind of seeing from those three?
So Shell is lining up with many languages. It's not just one. Like you would see Shell together with Python, together with JavaScript, together with Java. Typically, Shell in your code base, in your PRs is some of the DevOps or build code, etc., that it wraps your main code. That's the typical place where we see Shell.
Right.
So it goes along with many others, but it's a very almost, if you're a programmer, you also need to learn to know Shell, because you're going to have some interaction with Shell and Shell scripts as part of your code base, even if it's not the main language that you're using.
Well, this has been really fascinating, Yishai. I love that you've kind of dug in and found some of these insights. I know there are other areas like in pull requests, which languages are you most likely to find together that it could be interesting? I see, C files tend to have also C++ files. Makes sense. Are there any other insights you had or things that we haven't addressed that you want to make sure we bring up here?
So there's also the notion of PR size. Like, what is the typical size of the changes that you're seeing? And maybe you asked me earlier about things that surprised me. So, I mentioned that Java was pretty quick to review. That was one of the shorter languages in terms of lifespan, but it's one of the larger, like the languages that lead to larger PRs. That's kind of a mystery. Like the typical change to a Java code base in a single PR is on the large side, maybe even like double the average.
And that typically isn't correlated.
Typically,
Or reverse correlation. Typically,
shorter PRs lead to faster cycles. And I think it's also true, like within a language, shorter Java PRs are faster to review. But the fact is that Java tends to have larger PRs. I know it's a more verbose language. You type more to get your changes in Java than you would maybe in Python, but the review is shorter. So either people are already used to scanning through that, all those like what we call cruft in that additional changes in the required for Java, or there may be another reason why, despite having larger PRs on average, the process, the cycle to get them reviewed is shorter for Java in a pretty dominant way. So that's another interesting point, not fully explained to me.
I think it's fascinating to see these data points where maybe we don't have an explanation, but we're seeing some insights. And I know we're planning to iterate on this and continue to dive deeper in this research. So I'm excited as we have more people on board for LinearB, start aggregating more of this data. I think there's a lot we can do with this to help identify where there are issues for teams and kind of like raise these pain points and figure out how to help. So, one example of that, like we alluded to earlier, is our free continuous merge app we've developed to help teams route their PRs and cut their cycle time, cut their PR wait time. And that's our Gitstream app. You can find that at linearb.io/dev for more information. Other than that, Yishai, any last words here? It's been wonderful conversation. I've really enjoyed chatting with you about it.
Yeah, thanks. It was interesting for me as well. One other place where this kind of research can help us is, we provide industry benchmarks for different metrics and different, like, if I tell you your PRs spend 40 hours on average to get merged, that's a great piece of information. But to really put that in context, I need to tell you, is that a good number? Is that on the high or low end? By having this visibility into different behaviors of different coding languages, I can say, okay, your code is in Python. Here is how you stack up to the industry with your PRs. If your PRs take 50 or 60 hours on average, or typical PR, you are above what we see in the general population for Python. And then if you are in C++ and you're spending 70 hours to get PRs done, you're actually better than most and better than the typical for C++. So having that additional level of visibility into that breakdown for programming languages lets us create better benchmarks and better context on how do I stack up, or what is the expected behavior in my code base, in my stack, in my programming language.
That's a great point, because one team might think, oh, my 40-hour PR time is not great. But then you realize they're all coding in Ruby and you're like, actually, maybe this is pretty good given the concerns we're having.
Yep.
Had to get the Ruby shot in for you there at the end. Here to help. Well, great. This has been really fun, Yishai. It's always wonderful talking to you, and excited to continue to listen to your upcoming Dev Interrupted Hebrew episodes. Do you want to give us any sneak peeks into what might be coming on that side of the fence?
Yeah, we have a great lineup of guests coming into Dev Interrupted. I have a couple of sessions we recorded but haven't released yet. So great people talking about skilling up for developers and skilling up for VPs. Like, I have a special episode that's getting recorded about how VPs of engineering are getting skilled up. I'm going to have a panel with 3 or 4 VPs of engineering talking about specifically that. I have a very cool founder from a construction tech startup to talk about that. She was CTO and now she's CEO of the company. So I'm going to talk about that, like that transition from a CTO to CEO, which is pretty unique. So interesting to hear, her inputs and her experience on that. Yeah. So I'm really excited with the episodes that we already have, published and the ones coming.
And I'm excited to have you at Interact as well. We're going to have an incredible developer experience conversation with you and one of LinearB's team leads, Abhishag. We've got a lot of cool stuff coming at Dev Interrupted. So if you're not subscribed, you're just showing up here to trash on some other programming language, make sure to subscribe. If you haven't already, give us a review on Apple Podcasts. Helps the show a ton. If you enjoy the content, if you didn't, give us some feedback. We'd love to know. So thanks everyone for listening. And
yeah, but why don't you
coming on?
Why don't I'm inviting every one of the people listening to us. Send us a note with what is your PR lifespan? What are you seeing in your team? Like what language you're using and what's the typical lifespan for your PRs? Are you able to merge PRs in a day or 2 or 3 hours or a week? What do you see?
I love that idea. Yeah, if you're on YouTube, drop it in the comments. If you're not, jump to the DevNRP Discord, share that info with us, reply to us on social media. We'd love to know. This is the stuff that really gets us excited.
Yep.
And thanks all for listening.
Thank you.
Thanks for coming on, Yishai.